G'day guys, welcome back to Marky Mark's workshop and my 372 cubic inch small block Chevy build. In the last episode, basically we found out that the intercooler core was shagged, had a leak or a couple of holes, pinholes in the intercooler core, the cores themselves. So this time we're going to get the two new cores out. We've had some plates made up, we'll have a look at those in a moment, and we've got a little bit of work to do on those before we start welding and fabricating. We've got to make some tanks up for the ends of the intercooler cores, and we'll get it all welded, fabricated together. Following that, we'll then go get it fitted up on the engine. So let's get into it. The guys, Garrett and Amon out at PMD Australia, they helped me basically sort it out, getting some of these cut for me. We drew up a drawing and then sent them off to get cut up. I went and seen Ethan there last week and picked them up. So the holes here, just got to probably make them a little bit bigger, I think. Just clean them out with a drill, and then we'll get our cores out of the box, get them onto the bench, and basically see whether the tolerances are right for the cores, and then we'll start fabricating. Again, these are a couple of, well, what they rated to as a couple of 1,000 horsepower cores, two of those. We'll end up putting them together, welding them down the center of the seam here. TIG them up on both ends, then we'll make some tanks up that we will then weld to the outer side for the front and back, and then we'll manipulate our pieces here, our top and bottom plates. But I don't have a drill press here, so we're going to have to trundle off and drill these holes out a little bit bigger because they're a little bit smaller than 5/16. So here at Massives, and just drilling one of the last holes on the plate. So we'll get the other one done. The same, and then we'll make some spaces to go up between the two, bolt them together. Then we'll weld, we'll get ready. We'll weld this to the tank eventually, but then first up we've got to make end tanks. Close enough for the bush. Got right in the shed behind me, painting on the lathe. He's boring out some bits of steel. Drag the TIG welder out. We're going to give that a bit of a crack today. A bit of a practice run on some steel here because it's been a while since I've run a bead of aluminium TIG. So we'll see how that goes. Have got the intercoolers cores here. We'll have to get them set up on a flat plate. Get them all squared up, we'll tack them into position, and then go from there. So we've got the cores set up here on a surface plate. Earth from the TIG welder to the surface plate. Tried leveling the core up as good as possible. So we need to tack the core here, and at the other end then we'll turn it over, and we'll tack the cores on the other side, and that will join the two together. Then we'll have to weld the seam up in the guts on both ends, and then we'll make some tanks up. I'm using a Unimig TIG welder, little razor, 200 ampere, should do the job for us quite well. Just got this lightly clamped. These aren't tight. These are just sort of basically holding things together. Additionally, just to mention, clean up. Fit this with a bit of a parts washer and then a stainless steel brush. Polishing any oxide off of there. So we're welding on a clean spot of aluminium. Prepare for best results, hopefully. not the best. Need a few more amps, I think. Yeah, that there is not hot enough. Cranked up the heat a little more, and yeah, much better. Both sides again. So pretty well there is our core now. Now we'll clean up and we'll weld the two cores together and then measure up for our tanks. Alright, a little bit of solvent, just taking the oils off of, or greases off of where we're going to weld. Stainless steel brush. So the tank's going to be sitting on here and there's going to be water going through this section, through the centre. So we need to make sure we got a good weld that's not porous, with no holes down the centre here, because this is going to seal from the coolant that's going to be used in the intercooler circuit. Need to get more amps into this. Might have to use a bigger tungsten, I think. So I've done the weld off camera. See up here, it's quite high. The heat hasn't got into the aluminium, into the base metal, so it's sitting a bit proud, and then she started warming up. So from here on, the weld along here actually is nice and sunken and looks good. So I'll probably just go over this on the sides again, just to sweat it in a little bit more, and then we'll turn him around. And quite a bit of heat in this core now. And the other side as well. We'll weld it up down the centre. Righto, make some tanks. So cut the plates, made them up, and yep, made a bit of a boo-boo, a bit of a rookie mistake, in actual fact. So I bent the plates up, 45, pretty good, but yeah, we've got a gap here, and I cut the wrong angle into the corners of the plates, meaning I'm going to have to make these all again. What a pain in the butt. So, yep, take two. Went a little bit quick towards the end there. Crazy stuff. What's that? Remark the plate. Drill the holes. A little bit less angle here now. Get that sorted out with the help of my what do we got here? What do they call this? Mathematical instruments. Oh yeah. Oh well, let's see how it rolls. Got the plate on the old bender there, starting to bend her up. Just using just a smart tool with an angle meter on, so as I bend the plate, it gives me a bit of a reading. Close enough to 45 is going to be close enough for the bush, I think. Anyway, managed to get the two new plates made up for the ends. Again, there's the old ones. Got the angle cut wrong on the ends. These ones turned out pretty good. They fit the end of the core relatively snug as well. So we'll set this one up. We'll weld the corners and then we'll turn over and drill holes in the plates and fit in some dash 12 ORB weldings for the coolant flow. Got our tanks welded on. Very good. Now we're going to pressure test, find some fittings here. Got the gauge ready, something I prepared earlier. A couple of fittings which are not ORB, these are JIC, but the thread is the same and the size. So we'll put some O-rings down on here in this little corner and we'll screw those in. to the ORB fitting, so should go okay. The O-ring in there, that'll seal good. So we've just got the plug that goes into the cooler core air line onto the regulator. This is a regulator, adjusts the air pressure going into the intercooler core, and of course got a gauge to read what pressure we will be using. We're probably going to be taking up to 10-12 pounds. This system won't have any more than between 12 and 15 pounds on it in the vehicle, so we don't need to go any higher than that, being that it's a radiator cap that's going to be predicting the maximum amount of pressure in the system. Hopefully got enough water. There's a small gap in between where the two cores meet, so the air's just coming out of there as the coolant's going in. Connect that up. So we'll just screw the regulator down until we start seeing some air pressure. Let's go with 7 psi. We'll open the tap. We've got leaks going on everywhere. Fantastic. Got a few pinholes to seal up. Just in the old rig up. 13, 14 psi, no leaks. That's good. Well guys, it's been a couple of days since I've done any recording, but have been busy. In front of us here, we've got the core that we finished putting the tanks on, pressure tested, that's okay. We got our plates here that we had laser cut for the bottom and top of the core. Spent a couple of days in the machine shop. Thank you to Jared and Amon from PMD up there. They let us use their manual mill to basically mill out an angle on each end of the cut laser plates, or laser cut plates, and basically they sort of sit down so everything's nice and flush. Now the idea was, a bit closer I guess, was to weld the core to the plates on both ends, top and bottom, and then obviously bolt it together. But what I've decided to do is I'm going to actually use an RTV sealer to seal the joint around the edges of the adapter plate, or the sandwich plate, and the core itself. I guess the reason for doing that, my thinking, is a little bit more serviceability, and obviously a little bit more shrinkage in that during the weld process. If there's an issue with the tanks, I can probably quite easily, separate the two pieces and do a repair to a tank if I need to. Obviously, if it's welded, it's going to make it a little bit harder to actually unstitch all the weld and then do any repairs down the track. So that was the thinking there on that one. So I guess now we'll clean it up. We've got some acetone here, some inox. We're going to put the inox on some of the surfaces that we don't want the RTV to adhere to or stick to, and just a bit of parts cleaner in a bottle, dry it all up, and glue it together. Let's get up it. This could get messy. Backside. I think also So it's been a couple of days since we put the glue onto the core and glued on the top and bottom frames, but it's actually turned out not too bad. So really now it's ready for putting on the engine. We'll take it out, we'll give it a wash first, get rid of any grinding dust or whatever that might have been floating around. Got the engine uncovered here again. Yep, we continue, just waiting for the intercooler behind me to dry out. I've blown that a few times, got some terry toweling under it, trying to draw the water out of the core because it's quite fine. Next will be the plate here. A few plugs, get those in, MPT plugs. We'll get it set down on the manifold and torque down, following the intercooler core itself, and then the top hat. It's coming together, looking pretty good. So again on the manifold here, we've actually drilled this spacer plate, hold the spacer plate on 10mm, gone the next size up because this is quite heavy, this intercooler core. In fact, we might weigh it shortly, but and then on the intercooler core, the base plate, we've also done our own stud pattern or bolt pattern for that as well in the spacer plate, and these are also 10mm bolt. So we'll probably put a little bit of Loctite blue on there because these are internal. Not that we need it, but probably more just, I guess cheap insurance more than anything. Just out of curiosity, let's see how heavy this assembly is. 2.2 kilos, 11.4 with the hat on top, 13 kilos with some bolts and spacers and bits and pieces. 14 kilos, you might as well say. Pretty heavy. How tight? I don't know. Firm. Don't strip the threads. So sparingly put some RBT grey on the surface. I'm going to be using that instead of a gasket because I don't have a gasket. So this is the gasket, but this will work fine. Let's drop it on. It's got the bolt started, or pretty well in, but I think I might put some of these little lock style washers in underneath. Intercooler's on, starting to look pretty menacing. Think I might pull this off of the engine stand now and put it onto the startup stand. So we'll get it over to the overhead gantry here, and we'll lift it off the stand. While we've got it off, we'll put in the rear camshaft Welsh plug, and also the water jacket plugs as well on the back. And that'll button the back of the block up. I've just taken the corners off here, quite sharp, and then just give them a quick hit. Some memory tape. Coat the Welsh plug, and then put a lick in on the bore as well. The brass hammer, see if I can't get that in relatively square. A little bit more at the top. Alrighty. Put the adapter plate onto the back of the engine here. It's got a relief or a cutout for the back cam plug, I guess. On the Dart SHP though, we've got these extra galleries here, and the actual plugs stick out proud a little bit from the back of the block, so I'm going to have to
mark where to mill this out, so we don't get any interference between them plugs. There's sort of touching them plugs inside. So anyway, mark them up and then go see if I can borrow the mill again. Mill out the back of this adapter plate. I reckon that'll work out alright. See a couple marks here. So I gave Jared a call at PMD and, yeah, hey Jared, can I borrow your mill? Yeah, knock yourself out, Mark, you reckon. So, here I am at PMD and we are going to do a little bit of milling. Oh. That should just about do it there. Got the plate back into the shed. I think we've had a win. It's up nice and flush now. We've got the engine stand, well, the engine mounted on the start stand here. The engine stand, the start stand itself, it's got its own little fuel cell and a place to put a battery. We'll end up, I think, now we've got a fair bit to do still. We've got to get the flywheel on, we'll get the starter motor mounted up in there, got to get the accessories on the front, get the belt set up, alternator, air conditioning, compressor. We'll probably pull these manifolds off, the exhausts, just the manifold themselves. Are going to end up cutting, I think, these pyrometer adapters off the bottom here, and we're going to got a new style of pyrometer adapter weld-on that I'm going to use. So this is a weld-on and cap. You can see that the weld-on, this is CNC machine, 304 stainless steel, 716-20 thread, and then the cap is obviously got a 5mm bung in the center of it, so, and tapered, so when you screw it down, once you finished using it, it all seals up nicely. And then the other part is a weld-on, same 304 stainless steel weld-on. That bit welds onto the manifold. And then in there we have a little brass crush sleeve, I guess you call it, that goes in the taper, and then that then forces the brass sleeve down. So when you put a pyrometer, exhaust pyrometer in, you tighten that down and the sleeve crushes on the pyrometer, which holds it in place. And we'll have 8 of them in each cylinder. So when we've got it running on the dyno, we know exactly what the exhaust temps are doing. It'll help us dial in the fueling and a little bit of the ignition, etc. So we'll work on that. You can get these, if you're looking for this sort of thing, you can get this at rayerindustries.com. Yep, it's a new website, new shop that'll be opening very soon. I can guarantee that. And lots of little tuner and fabricator tools, well, not so much tools, but hardware that you'll be able to purchase and use, order online. So anyway, we'll be doing that shortly as well, getting those welded on, and then we'll get the turbos mounted, the pipe work, for the turbos, the cooling in and out of the turbos, the oil feed, and then the oil drain as well from the turbos. And then after that, we'll probably go for a start, get all the wiring connected, the loom, the harness fitted, and then yeah, prime the system up and give it a crank. Let's wedge the flywheel on. using an ARP bolt. Just a bit of 30 weight oil on those, and then we'll torque them to 80 foot-pounds. Do them up in stages. Whatever, 30 or 40 or whatever. Beautiful. So the next thing we're going to do here, guys, is install the filter adapter into the block. It fits up into here with a couple of bolts. I've just got a couple of Allen-headed bolts here. Going to put a little bit of gasket sealer, Loctite 515, I think it is. Yep, or no, 510 onto that surface. It's not necessary, but I'm going to run a little bit on that, and then probably a little bit of Loctite blue thread locker just on the studs to retain that into the block. Not that I need it, but I'm not going to over tighten these, being aluminium, and so I'll let the blue do its thing and help retain that bolt into the block, keeping the adapter in place. The other thing is I'm using an aftermarket adapter here. This does not have a filter bypass check or valve in it. A lot of the OEM style adapters have what they call a filter bypass valve, and that's basically to save the engine from a block filter. So as the oil comes up inside your filter, goes through your paper and then down to your engine, if that paper element blocks up, obviously you're not going to get oil to your engine, which is engine death basically. So what the OEM do, they put a little check valve or check ball in here, so if that blocks up the pressure differential across the paper element, it'll force the check valve open or check ball open and allow oil to flow, bypass your oil filter and still supply lubrication to your engine. In my case, I don't want that to happen at all. I want every bit of oil going into my mains and big ends to be filtered 100%. Obviously, on cold startups as well, that's another reason they have the bypass. You know, in the morning, cold, you start up. If you're giving the engine a bit of a rev, you got more flow because the engine oil is more viscous because it's cold. It's a lot harder, makes that a lot harder to go through the paper element. Again, another reason why I have the bypass valve, check valve in the adapter, and that will let some oil past the filter, bypass the filter and into your engine. Some oil's better than that, I guess. Anyway, like I said, my application, I don't want it all. I want it all filtered 100%. Just means that I need to keep on top of my oil servicing a little more. Filter changes as well, intervals. I don't do a lot of miles or kilometres in the vehicle this engine's going into, so it's not really a drama for me. I don't do a lot of miles in it, but when I'm out in the track giving it some curry, yeah, I'll periodically, pretty well, you pull a filter, cut it open, have a look, see what's going on. Not necessarily change the oil, but definitely cut filters open and have a look, see if the engine's making any metal. Anyway, let's get this installed. All right, let's lube up the bolts with a little bit of Loctite blue with a bit of luck. Gonna get any out of this? Come on, looks like I need a new tube. Not too much on there. That's more than. Next up, we're going to install the remote oil filter adapter that screws onto the oil filter adapter on the block. Yep, it's just oil feeds out off to an oil cooler, well, off to the filter, then the oil cooler, back from the oil cooler, into the engine. So nice cool oil, or cooled oil, comes out of the centre and into the engine. Oil galleys to feed the crankshaft and top end, etc. Anyway, let's install this one. The adapter has an O-ring on this outer surface here. We'll just put a little bit of fat on that, bit of grease. And then feed that on. And that's that.
So we've gone ahead and fitted up the oil system, the oil cooler here, and then the accumulator. Obviously the adapter, the lines to the adapter across the oil filter. And then next thing we've got to sort out is the turbo drains. Oil drain. Clean that up and we'll put the adapter on, and we've got to make a bit of a pipe work that will run underneath the turbo here, miss the exhaust manifold bits and pieces, and then end up down in our sump. So I'll probably make this out of a little bit of aluminium with a couple fittings, and then have a small piece in the centre, just a bit of rubber, just for a bit of flexibility. They were hard all the way, and when pulling turbos on and off, sometimes it can be a bit challenging. Pain in the butt to get the lines connected both ends. So we'll put a bit of a flexible joint somewhere in here, and go from there. Also, I'll have to make something up for the turbo feed. This will be the point where I'm going to pull the oil for the bearings for the turbos. And then, yeah, continue just scratching around, I guess. The other thing that we'll need to do is from the turbo outlets, got to start thinking about how I plumb all that into our throttle body up here on the intercooler core. So, bit to consider yet. 4 or 5 hours just sitting down thinking about how things are going to be plumbed and routed, and then, you know, decide which way to move forward. But anyway, we'll get amongst it. Make these drain tubes up for both the turbos left and right, and then we'll fill the sump up with some oil, and we'll prime it up. We'll make sure we got lubrication to the top end, and we'll put the rocker boxes on, seal them up, and then yeah, start laying in the turbo feed lines, coolant lines, put the engine harness or the loom in for the electronics, and fit the accessories on the front. Let's up it. Well, it's been a couple of days. I've had the sump off and the inlet manifold off because I filled it up with 80-90 gear oil. We started to fill it up with 80-90 gear oil that wasn't even new. It was old 80-90 gear oil in a engine oil container, and so I started pouring it in because it looked good, and then about 2 litres in, I'm thinking, this doesn't look right. No, this doesn't smell right. Damn, this is gear oil. So there's a bit of a setback. leading to that, I didn't turn the engine or pre-lube it, thank God. Otherwise, I'd have to strip the engine completely down again. So off comes the sump and the inlet manifold, rod covers off, flushed it all down from the top down, cleaned it all up, and looks good. Then I put the sump back on, poured oil in it, the correct oil, proper oil, like engine oil, because 89 is not good at all, like destruction, bad. And then I pre-lubed the system with one of these, which drives the oil pump down from the top, and we have oil up through lifters and push rods, and all the rocker gear has oil to it. So the system's lubed up with the right oil in. Now we're just going to make a couple bits and pieces up for the turbos, the drain, or not the drain, the drains we've made up, and then also a bit of an oil feed, a bit of a pipe. We've got some Bundy tube here. We're going to bend up some tube, flare the ends, and make a little tube up from the block to the oil feed turbos, the lines that feed the turbos. So anyway, there's springs out, my nose is running, so let's get into it. So this is the original pipe that, well, in the original block, the discharge for the oil out of the block is in a different spot. So that's not going to fit, so we need to make this little piece up here, and that just tees off here and then feeds the turbos. Let's just run through flaring one of these, I guess. First thing is clean or deburr the inside of the tube here with just a tool like that, goes in. And not rocket science, put a twist, taking the burrs out of both ends, because when you cut it with the cutting tool, it sort of collapses in a little bit and leaves a little bit of an edge. Then this is 1/4 inch, so we'll set it up that one there, 1/4 inch, get it right. We have this little arbor, I guess, or a little adapter that actually goes in there when we flare, but we poke the end of the tube out the same distance as that. Looking pretty good. Tighten these chaps up. You don't want the pipe to be moving. And then insert. Use the tool as it winds down. Pushes this in onto the end of that, which will give us a nice bubble, all going well. Here is a bending tool that bends the pipe. This one does 3 different sizes of tube. 1/4, 3/16, I don't know what that is. 1/8 maybe. Anyway, yep, so again, pretty simple stuff. Gonna want this pretty tight, like so. When I come back on itself a fair bit. Let's get it on, see how she looks. I am having second thoughts. Like I said, I'm having second thoughts. Sort of, this is sticking out a fair way from the side of the engine, so I might see if I can get a 90-degree fitting in here, and then I can hug it a bit closer to the block. Less chance of it getting knocked as well. Search for some fittings, I think. I found another fitting here. Looks like it might do the job a bit better and stay a little bit closer in to the block. So we'll use that and make the tube up. Mission accomplished. Done dusted. One of the things with the lower mount alternators here, especially the serpentine belt, they have a tendency to, just with these two bolts on the top bracket, has a tendency for the alternator to actually sort of move sideways or flex on those bolts, because I've got the serpentine that obviously drives that and the aircon compressor as well. So there can be a fair bit of load on it. So I've made this jinky little thing up the back there that this thing here that basically goes up under the engine mount like so, and then ties up down the bottom with a bar or a extended bolt to a bracket that will help. Well, it does actually helps stiffen that whole arrangement up on the engine. Well, yep. It's getting late. We are continuing dumbing the engine up on the stand. I've sort of gone through connecting all the wires, the ECM boxes, ignition modules. So we've got the SM4 here, we've got the MSD6A. Obviously we've got the coil, some relays, and the aeromotive fuel pump relay. Sort of need all this here to make that breathe a bit of fire. So right now I've just checked the ignition timing with injector timing for injection. I had some concerns whether the injectors were actually squirting at the right interval or degrees of crankshaft rotation to the ignition. Having a distributor allows me to set the ignition or the spark plug basically anywhere I really want to. So the thing is, I wanted to know that this from ICE Ignition, this distributor here has two sensors. It's got a pickup for each cylinder. There's an 8 cylinders Hall effect, and it's also got a pickup for position. So number 1 top dead center, and then the other sensor counts the number of cylinders, which is 8. Obviously, setting up in the ECM, you can set the offset for the injection timing. And so just to double check, or have more of a sanity check, was to get the oscilloscope out and just confirm that we've got injection timing 360 degrees away from crankshaft rotation. That is 360 degrees of crankshaft rotation away from ignition timing. That way I know ignition timing, we're going to get combustion, and then 360 degrees later, we're going to get induction and the injector spraying into the correct cylinder. So I'm front, got the laptop here, and this is the oscilloscope traces. The top one in yellow is the injector pulse, and that is from injector number 1, cylinder number 1. The green line here is the Hall effect, or the square wave, from the 8-cylinder pickup in the distributor. And the blue line is the single pulse per revolution of the Hall effect pickup in the distributor. So in between each one of these singles, we've got eight pulses, or 8-cylinder pulses between each one. And what we're looking for is the ignition and the fuel injection. This is fuel injection here, being 360 degrees apart, or 4 pulses apart from each other. So we want the ignition timing to be on this line here. Get a bit closer on this line here, and then count 1, 2, 3, 4, and then injection, which will be intake. I don't have the pink line. The pink line is the ignition line off of the ignition lead on number 1 cylinder. When I'm doing the test, I'm getting a bit of interference from the ignition system. So just to clarify, this from this line here is definitely
1, 2, 3, 4, and we're getting injection sequence on that 4th bar. So I'll set it up. I'll reconnect the ignition system, disconnect the injection, and we'll run the test again, and we should get the ignition happening just in front of this green line or this blue line here. All right, got a little start station here. Turn the ignition on, and then we'll just reset, start this tracing again, and then we will hit the start button. It won't start, it'll just turn over. Spark plugs are out, so it should turn over pretty good. And then we'll see the purple trace below. That should give us some ignition pulses, being a CDI or capacitive discharge or multiple spark discharge. There'll be probably a few lines batched up together, but we're interested in where they line up with the pulse for engine position, and then also the count for the individual cylinders. I've disconnected the yellow line, which is the injection line, because that just picks up too much interference and it'll just confuse things. So anyway, let's give it a whirl. And stop record. And so we can see that indeed ignition is basically spiking or coming in just before each of these position, which will give us where the yellow line was 4 pulses apart. So basically, in short, I know we're going to get ignition is going to be right because it's going to be firing, and we're going to get injection 360 degrees apart from the ignition timing, meaning that the fuel injector will fire when the inlet valve is open and we're taking in air and fuel mixture. So finally, here we are. We are ready to fire this bad boy up, or girl, or what do you want to call it really. We've got the radiator on the front. We'll have a bit of a walk around. It's taken some time to get things together here. We went through last night checking out the with the oscilloscope and having a look at the ignition timing versus the injection timing for the fuel. That seems to be okay. We're going to fire it up now. We've got the radiator on the front. We'll do a little bit of walk around the engine here, and we'll have a bit of a look at what's going on with the electronics and the fuel system and other bits and pieces. It's taken a bit of time to get to this point, but we're here. We've got a few things left to do, but for the moment I just want to get this thing started so I can check for leaks and any coolant leaks and make sure my electronics are working good, and then it should be good to hit the dyno. We don't want to have those issues while on the dyno and trying to sort through that, because dyno time can be expensive when you're trying to sift through problems with the engine. But anyway, let's have a bit of a look. Let's drink it up. In the bottom of the stand, we've got the fuel cell, and out of the fuel cell, we've just got a supply to a 100 micron filter into a Bosch 44, A44. That then feeds up into a secondary filter, which is a 10 micron, and then it feeds the swell tank or feed tank to the secondary pump, which then goes into a 100 micron filter, and then onto the Aeromotive fuel pump. We're also running an Aeromotive fuel regulator, rising rate regulator, so as boost increases, so does the fuel pressure. From there, the turbos, we've still got to make the turbo pipe work up to the throttle body. Like I said, that's to come. I haven't made that up yet, but when we hit the dyno, that'll be the least of our problems. What I'm interested, like I said, is to ensure we don't have any oil leaks and coolant leaks, and the electronics are working on the engine. Talking about electronics, again, here we are. Here it is. To make this thing breathe fire, we've got the MSD 6A ignition module, the Autronic SM4 ECM, a bit old school, but really all I need is fuel and ignition, because the car is pretty well analog
yep, she's pretty well a manual. There's no can or anything, and it's a manual transmission, so I don't have to really worry about the IOs and driving anything through CAN bus. Got the ignition coil here, relays, the relay here for the fuel pump, and that's about it. We do have obviously the oil system running into a remote oil filter with a Carnan filter onto that, equipped with an oil cooler on the side of the engine, along with a AccuSump accumulator, which we're going to hook up in a minute once we've identified we've got oil pressure. And that is that. Alright, let's give her a crank. Is the camera, are we talking?
No, I don't think so.
How are we going? Yeah, we're talking the grim doodad there. Alrighty, let's give it a crack-a-lack. We've just had a look, and the fuel pump has been sitting for a while. There is actually a small leak out of the housing, so I don't know if I can get a gasket for that or not, but that needs addressing. It is leaking a little bit, but we're still going to start it and go from there, check out the oil pressure, and then we'll set the ECM ignition timing to 10 degrees and then hopefully adjust the distributor with a timing light to get it 10 degrees. Hopefully it'll keep running and we can adjust that up. Alrighty, contact. Didn't like it at all. So tried doing the fixed ignition, which sets it at 10 degrees. So we might go into the ignition table, turn this off. We might go into the ignition table and set that to, I don't know, 20 degrees or something at idle. We'll start it again, see what we're sitting at. We'll get there. Righto. This might prove to be a bit trying. So we're going to get decent idle out of it. Ain't liking it. We're gonna have to figure out why it's not running. Might need some more fuel. We'll have to check it out. All right. So we'll try start it again. I'll see if I can get a decent AFR read and see what we're doing with the fuel mixture. We'll probably run a bit lean listening to that, but we'll have a look. Anyway, let's give it another crack. Oh yeah, we're lean, I think. Same with Rich. That's not making sense. All right, need to think about this for a bit. Well, that's it for this time round. We got good oil pressure. Idle's about 70 psi. Give it a bit of a rev and she's up around 90, so we got more than an adequate oil pressure. For now though, that's this one done and dusted. The next time you see this, it will be on the dyno. I've got to make the pipe work up, so before I start mucking around with air, fuel and IAC valves and other bits and pieces, idle air control valves, we'll get the pipe work on into the throttle body, so it's a closed system, and go from there. Also need to make the pipe work up for the intercooler box as well, but that'll have to wait until next time round. This time we don't have any major oil leaks to be really concerned about. It's running, we've got good oil pressure, it seems to be sound. So that's it for this one, guys. Until the next one, you'll see us on the dyno. Alrighty. Well, we'll try it again.
Hang on. It's looking at me.
There's it. Oh, turn it around. Little doodad there. Down the corner here. It'll spin it around. There we go.
Hello.
Right, we're away. Hang on. Righto. We'll give it a crack again. See if we can get a run. And then check the timing. Make a bit of adjustment. Timing is about right. It's about 39 degrees, which is about right for this thing. Well, that's what the ECM at that RPM asks for, is about 39 degrees before top dead center. So we're about there, within 1 or 2 degrees. Okay, that's it.